All right, guys, we're going to go over the review. I'm not sure if we're going to do this in one video or not. I guess you'll probably find out when you see them posted. But some of these first questions, there's a lot of reading going on. I'm just going to show you the correct answer. I'll let you read through what answers are incorrect, unless there's specific things that I want to point out. So number one, what is logic? The answer that we're looking for is answer B. Logic is the study of methods and principles of reasoning. It can be useful in providing strong support for conclusions. Okay. These other ones have some truth to them mixed in there, but that is the best explanation that we got. All right. Number two, how do we define an argument and what is the basic structure of an argument? Now, an argument is a reasoned or thoughtful process. A and D aren't very good examples, but B is one that you could almost convince me that that is a good definition. The way the book refers to it is more in line with number C right there, that it's a reasoned or thoughtful process. And then what is the basic structure of an argument? So an argument consists of premises that are used to support a conclusion. At least that's how it should be. All right. We all know that that's not how they all go, which brings us to number three, which are the fallacies. So it asks for a definition and then which of the following are examples of fallacies. So a fallacy is a deceptive argument. It's an argument where the conclusion is not well supported by the premise for one reason or another. And then it gives us four examples here and wants us to choose which ones are fallacies. A says that the patient is breathing, so he must be alive. That seems like a pretty good argument to me. It says that it's deceptive because it generalizes. Well, no, I think pretty worldwide, if you're breathing, you're alive. I don't think that's a generalization. Company A makes the best pickup trucks in the world. We actually saw this example. Well, just because lots of people drive that truck doesn't mean it's the best truck in the world. So that's one of those appeal to popularity fallacies. C, I placed the quartz crystal on my forehead, and in 5 minutes, my headache was gone. Again, that's a fallacy if you're going to use it as an argument, because just because you placed the quartz there, that doesn't mean that that's what made your headache go away. So that's the false cause or the causation fallacy that we talked about. And then the last one, society has an obligation to, finishes on the next page, provide health insurance because healthcare is a right of citizenship. Again, that's a fallacy. That's the one that we call the circular fallacy because the premise and the conclusion kind of say the same thing, just in different words. Okay. Number four, consider the following example of a fallacy and identify the premise and the conclusion. So it says that he refused to testify by invoking his Fifth Amendment's rights, so he must be guilty. So the premise is that he refused to testify. The conclusion is that he must be guilty. So we look for that first. He made premise, he refused to testify, he must be guilty. So that's the one that we're looking for right there. Now the reason this fallacy occurs is because it treats it like the only reason he wouldn't testify is because he is guilty, where there might be other reasons that he doesn't want to testify. So we're looking for D right there. The conclusion is stated as if it were the only possible conclusion. All right, so moving on. Number 5, consider the following example of a logical fallacy of the straw man. The mayor wants to raise taxes to fund social programs, so she must not believe in the value of hard work. So the premise is that the mayor wants to raise taxes to fund the programs. The conclusion is that she must not believe in the value of hard work. Because she wants to raise money for those programs, the conclusion, she doesn't believe in hard work. And then the last one here, briefly explain how straw man occurs in the argument. Well, this one is saying that the mayor, it's kind of characterizing the mayor wrong by just one quality on which they're basing this conclusion. Just because she's in support of raising these funds doesn't mean that she doesn't believe in the value of hard work. But that's what it's trying to convince us of, okay? So number 6, in the following argument, identify the premise and the conclusion, explain why the argument is deceptive, and if possible, identify the type of fallacy. So everyone loves Shakespeare because his plays have been read for many centuries. So the premise is that everyone loves Shakespeare. Well, no, just because it comes first, I disagree. I think that we would say that the premise is that his plays have been read for many centuries. The conclusion is everyone loves Shakespeare. It just puts them in the opposite order. So be careful of that, because I almost just marked the wrong one. The premise comes last. The conclusion comes first. And then it asks why this is deceptive. And what we're looking for is kind of the false connection there. So I'm looking for that it's deceptive because it assumes that a lot of people are reading Shakespeare's play as evidence that they actually like it, which, there it is right there. These other arguments, it's deceptive because it makes a generalization about people who read Shakespeare. That's close. The argument's deceptive because it assumes that because Shakespeare's plays have been read for centuries, his plays are good. That's not necessarily the case. But it's not talking about whether they're good. It's just talking about people loving them. Okay. And then the last question is which type of fallacy this is using. Circular reasoning, no. This is definitely a appeal to popularity. Okay. Just because they've been read for a long time doesn't mean that everybody loves them. All right. So number 7, determine if the following statement is a proposition. So remember, a proposition is a full sentence, and it's either a true or false statement. So this one says the game of baseball was invented in 1845 by Alexander Cartwright. So that's either true or false, and it's a full sentence. So I would say not A. I would say not C. I would say yes, because the given statement can be either true or false, and it's a complete sentence. Okay. It doesn't necessarily have to be true. It's just stated that it's true. So you wouldn't pick D because D is saying that it is true, and it may or may not be. That's not what makes it a proposition. The fact that it's either true or false is what makes it a proposition. Okay. Then it says to write the negation of the proposition. Mars is the third planet from the sun. So remember, negation basically just adds the word not in here. So Mars is not the third planet from the sun is what we're looking for as the negation, which is A right here. Mars is not the third planet. The truth value of the original proposition. So Mars is the third planet from the sun. I believe that's false because isn't Earth the third planet from the sun? And the truth value of the negation would be true, that Mars is not the third planet from the sun. Apparently, we need to do a little bit of astronomy practice before you take your math test. Hopefully, that's not going to show up as specific on the test. We'll keep an eye out for that one. Number 9, make a truth table. The letters Q and R represent propositions. So complete the following truth table for Q and R. So the key word here is and, meaning for this to be Q and R to be true, that means that Q needs to be true and R needs to be true. So this one's going to be true. Here, they're not both true, so it's false. Here, only one of them is true, so it's false. Here, they're both false, so it's definitely false. Okay? And I think that's going to be the only one on that page. So number 10, the statement below connects two individual propositions with the word and. State the two individual propositions and if they're true or false. Okay, so it says 3 plus 8 equals 10. Well, first of all, no, it doesn't. And 6 times 6 equals 72. No, that one does not either. So the first proposition is that 3 plus 8 is equal to 10. The second proposition is that 6 times 6 is equal to 72. Is the first proposition true or false? Well, I don't know what world you live in, but hopefully in your world, 3 plus 8 is not 10. And is the second proposition true? 6 times 6 is not 72. So that one would also be false. So then it asks, is the overall statement true or false? Is the statement that both of these true or false? Well, the statement is definitely false because the first proposition is false and the second proposition is false. Okay, there's another one down here that says it's false because the first proposition is true. Well, no, it's not. The first proposition is absolutely false. So number 11, make another truth table. Assume that R and S represent propositions. So this one says R or S. Now, it doesn't tell us if that is an inclusive or, so we assume that it's inclusive. So it can be one or both, but both of those would be true. So if this one says that R is true and S is true, so we're going to say then, yes, the overall statement is true. This one says that R is true, and even though S is false, because R was true, the overall statement is true. Here's our false, but here's our truth. So again, because of that or, we know it's true. False, false, neither of these are true. So that would be my false statement right there. All right. Number 12. Identify the hypothesis and the conclusion in the following proposition and state their truth values. So if trout can swim, then trout are birds. So my hypothesis is that trout can swim. Right? That's my if part. If trout can swim, which they can, that's a true hypothesis, right? The conclusion is that the trout are birds, which is definitely false. Okay. If this is true, then this is true. Well, no, that didn't happen. So the entire proposition is false because the first one was true, but the second one was not true. So we can say the entire proposition is false. Okay. All right. Moving on to number 13. We're almost getting to some actual math now. Write out the 3 steps of the understand, solve, explain process. How much does a typical waterbed weigh? And it kind of gives us a little math problem here to do. So it says, what is the unknown in this problem? So what are we looking for? It's asking how much a typical waterbed weighs. So it's asking for the weight of the waterbed. That's the question. That's the unknown. And then it asks us, what is the weight of the waterbed? And it gives us some information up here. It says that 1 cubic feet of water, so 1 cubic foot of water weighs 64.2 pounds. And a typical waterbed holds 28 cubic feet. So you can either set up a proportion and put the 28 cubic feet up here, and then cross multiply and divide by 1, or you can just take your 1 feet of water that weighs 64.2 pounds and times those two together. So we're going to take 28 cubic feet of water, times that by the weight of a cubic foot. That's a lot of weight. 1 cubic foot, a 1 by 1 by 1 chunk of water weighs 64 pounds. And my answer is going to be 1797.6. Now, be careful when you put in your answers. It'll usually give you how it wants it to be rounded. In this case, we've only got 1 decimal, so I started to read ahead. I'm going to assume that it wants that 0.6 there because it's just 1 decimal place. Now it wants me to explain how I got the answer, why that makes sense. Well, that makes sense because 28 cubic feet times my pounds for each cubic foot is going to give me the answer that I'm looking for. And I'm going to have the 1 cubic feet on the bottom that's going to cancel out this. So I'm looking for 28 cubic feet times 64 pounds. I'm just looking for the math that I did to get the answer, which is C right here. The weight of the water can be calculated by, you take the feet, the weight of 1 pound and or 1 cubic foot, and you multiply that by the number of cubic feet. Okay. All right. Oh, look, it was a multiple choice. So we didn't have to pick. It gave us the options right down here. And it's the weight in pounds, not cubic pounds. So be careful when you answer that one. Okay. All right. Number 14. Write out the 3 steps again. This time we are using a new problem. How fast does the Earth rotate? Note that in 1 full rotation of the Earth, a point on the equator travels 25,000 miles in 24 hours. So what's the unknown? We don't know the speed of the Earth, how quickly it rotates. So that's what we're looking for. What is the speed of the Earth? Well, if I take a point on the equator, and in 24 hours, that point rotates all the way around and goes 25,000 miles, then I want to take that 25,000 miles that it went, and I want to see how fast it's going each hour. So I'm going to take my miles and divide it by my hours, because I want to get my miles per hour. So we do 25,000, 25000, divided by 24. And that's 1041.6666667. And I'm assuming, it's going to give us multiple choice down here. So we're looking for this one right here. It's rounding it to 1041.7 miles per hour. And if you know that you're looking for the speed, you can eliminate those two really quick, because neither one of those are speed. One of them is time, one of them is miles. So the only other option are these 2 miles per hour. And I'm pretty sure the Earth doesn't rotate that slow. So you could have done this without any math at all, just by working through the problem solving of that. Until this part, explain why that makes sense. Well, we took the distance, we divided by the time, and that gave us our speed. So I think A is going to be the right one right there, right? Distance divided by time is giving us the speed that we went, the Earth rotated. Okay, number 15. How much will a person pay for 13.3 pounds of bananas if bananas are $1.39 per pound? So we've got $1.39 per pound, and we've got 13.3 pounds. So I better put a per there, per pound, and I'm going to times that by the 13.3 pounds. So I get 1.39 times 13.3, because that's how many pounds I have. And I get 18.487. So the problem is, that's not a very nice number. It asks us to round to the nearest cent. Well, the nearest cent is the nearest penny, which is my hundredths spot right there. So it's going to round to be 18.49 dollars. So $18.49. And you're probably not going to put the dollars there. You're going to use dollars. It looks like it has a place for you to select the units. Okay. Number 16, Sid needs 0.5 meters of canvas material to make a carry-all bag for his wheelchair. If canvas is $8.19 per meter, how much will Sid spend? So he only needs half of a meter. So I'm going to take my 0.5 meters that I need, and I'm going to times that by the price per meter. And that's going to give me the cost. So that's going to give me my 0.5 times 8.19, which is going to be $4. And it says, again, to round to the nearest cent as needed. So $4, and we'll say that's going to round up to 10 cents. So what's happening in the units here is I've got 0.5 meters that I need, but I'm looking for what the cost is going to be. Well, my cost is $8.19 for 1 meter. So here's where I'm canceling out my meters. And because this is just a 1, all I had to do is multiply the tops. And that got me my 4.095. So that's where that the cancellation came up in that one. Okay, number 17. Moving right along. Hey, we're getting there. About a third of the way through now. Find a conversion factor between square inches and square feet. Write it in 3 forms. So I want to go from inches to feet. So on top, I'm going to put what I know about inches and what I know about feet. So I know that there are 12 inches in 1 foot, right? So, but I don't want inches and feet. I want square inches and square feet, which means I'm going to square everything on top and square everything on the bottom. So this becomes 12 squared inches squared over 1 squared feet squared, which is just 144 inches squared in 1 square foot. So that's what I'm looking for. I guess I should have looked at what it's asking. Write the conversion factor in the form of converting square feet to square inches. So it wants me to go from feet to inches, which that works out okay because I've got my feet on the bottom, so that's going to cancel out. So I'm going to find out that in 1 square foot, that's what this 1 stands for, in 1 square foot, I have 144 square inches. So I'm looking for 144 square inches right there, C. Okay. Then it asks, write the conversion factor in the form of converting from square inches to square feet. So instead of going from inches to feet, or from feet to inches, it wants me to go the other way. So all I have to do is flip it over. It wants me to go the other way. It wants me to go from my inches to my feet. So we flip this over, and I'm looking for 1 square foot on top and 144 square inches on the bottom, which is that one right there. Okay, so this one we went from inches, and we wanted to turn that into feet. And up here we went from feet and turned it into inches. All right. 18, you return from a trip with 160 British pounds. How much are your pounds worth in US dollars? Use the exchange rate shown below. So it tells me that US dollars per British pound. So that tells me that there's $1.531 per 1 British pound. I don't even know what the symbol for pound is, so let's just use P. This one right here tells me that there are 0.6532 pounds, British pounds, for 1 US dollar. So it's telling me that I came back with 160 British pounds. So I've got 160 pounds, and it wants me to convert that into dollars. So I'm looking for the conversion that changes the top into dollars, which is this first one right here. Because the pounds are going to cancel out. So I've just got 160 times 1.531. So 160 times 1.531. Hit enter, and it tells me $244.96. So 244.96. You don't need to write that $sign. I'm in the habit of doing so, but it has the $sign right there in the answer for you, so you don't actually have to include that part. All right. Okay, number 19. Well, we're running on 25 minutes already. So decide which of the 2 given prices is the better deal and why. So you can fill a 12-gallon tank for $24.30, or you can buy gas for $2.20 a gallon. So I want to compare these 2 prices. The problem is this one is a 12-gallon tank. So I want to take that 24 $24.38 and divide that by my 12 gallons because I want to know what the price is for 1 gallon. So I'm going to do $24.38 divided by 12. So 24.38 divided by 12. And that's going to give me roughly $2.03. I'm going to go ahead and round up to 4 cents because that's what the gas tank's going to do anyway. So which is the better deal? Well, the other option was to buy it at $2.20 for each gallon. So clearly, buying it in bulk is the better deal. So the better deal is to fill a 12-gallon tank because the price to fill that tank is $2, and it wants me to round to the nearest cent, so I better put $2.03. Even though the bank and the gas station and the store are usually going to round that up to 30 or to 204, we're going to go ahead and use normal rounding rules and put 203. We'll try and follow it that way. Number 20, complete the following sentence with a power of 10 greater than 1. So a square meter is blank times as large as a square decimeter. So I'm comparing meters on top to decimeters on the bottom. So a meter, remember, is just 1. A decimeter is 10 to the negative 1. Is that really all we're comparing? No, we're comparing square meter. Okay, good. So I've got 1 meter on top, and I'm comparing that to 10 to the negative 1 decimeters, right? So, but I want squared. So I'm going to square this one. I'm going to square this one. So that becomes 1 on top, and on the bottom, I get 10 to the negative 2, which means that when I move that up, my 10 has a power of 2. So a square meter is 10 to the second times as large as a square decimeter. All right. Okay. I'm trying to get this metric prefix on your actual test form, but it looks like the questions that use it include it, which is a nice change that they've made built into the program. Now it wants us to compare cubic meters to cubic picometers. So again, I'm going to put 1 because that's my value for meters is just 1, and the picometers is right here. That's 10 to the negative 12th. But I don't want just my first power. I want this to be cubic, and I want this to be cubic. So that's going to become 1 on top, and this is going to become 10 to the negative 36. So when I move it up, that's 10 to the 36 power, which means that a cubic meter is 10 to the 36 times as large as a cubic picometer, which that's a lot of zeros. 10 to the 36. Yeah, we're 10 units up. That's a whole bunch. So 22. Convert the measurements to the units specified, 18 pounds to kilograms. So if I'm starting with 18 pounds and I want to change these into kilograms, that means whatever I multiply by, I need kilograms on top and I need pounds on the bottom. So I look for that ratio of pounds and kilograms, which is right here. So the 1 goes on the bottom with the pounds, the 0.4536 goes on top with the kilograms. And when I put that in my calculator, 18 times 0.4536, when I hit enter, that gives me 8.1648 kilograms. And then it says round to 2 decimal places. So 8.16. I'm rounding to that 6th place, that 100th place, which is a 6, and the 4 tells me to round down. Okay. More conversions. Convert the following temperatures from Fahrenheit to Celsius. And it gives me the formulas. This is my Celsius formula. This is my Fahrenheit formula. So it wants me to go from 30 degrees Fahrenheit to Celsius. So the first one I'm going to use for part A is I know the Fahrenheit. I need the Celsius. So for part A, I'm going to put 30 degrees minus 32 divided by 1.8. So when I put that in, 30, be really careful. When I minus the 32, I'm going to hit enter before I divide because my calculator follows order of operations. And it tells me that that is negative 1.11111, and it wants me to round to 1 decimal place. So negative 1.1. Then it wants me to go from 40 degrees Celsius to a Fahrenheit. So I'm going to use this formula for the second one because I know the Celsius. So 1.8 times my Celsius, which was 40, plus 32. So when I plug that in, 1.8 times 40 plus 32. I don't need to worry about hitting enter on that one because I'm following the order of operations as well. So that says 104 degrees Fahrenheit. Okay, so that's getting pretty warm. That's probably about what it was today. Now, negative 30 degrees Celsius. So again, I'm going to use this same formula because I know the Celsius, I want the Fahrenheit. So Fahrenheit equals 1.8 times negative 30, and then I'm going to add 32. So 1.8 times negative 30, and then I'm going to add 32. And I end up with negative 22 degrees Fahrenheit. And I don't think we need to worry about any rounding there. That looks pretty good to me. Okay. All right. Moving on. I think that's the last one for this page. We are officially halfway through the review, which has you super excited because you're at home working on these problems on your own, right? So it says that it wants us to express the given decimal as a percentage and as a reduced fraction. So 0.40 as a percent, that's just 40, and it gives me the percent sign. And to reduce it as a fraction, there's a few ways that you can do that. When I read 0.40, when I read that, that's 40 hundredths. So I write that as 40 over 100, which reduces to that 0 cancels out. So that goes down to 4 over 10, but that also reduces down to 2 over 5. So my reduced fraction would be 2 over 5. If you're not very good at reducing fractions, your calculator can help you out. If I take 0.4, which is my decimal, and I go math, enter, enter on my calculator, it turns it into the fraction and it tells me it's 2/5. All right, 25. In the following statement, express the first number as a percentage of the second number. So a certain candidate won 243 votes out of 414. So I'm just going to write that as a ratio. He won 243 votes, or she, I guess, out of 414, or it, or banana, or train, whatever our candidate is, right? 243 divided by 414. I just plug that in, 243 divided by 414 equals 0.58 6956, and it wants that as a percent rounded to the nearest tenth. Well, remember, percents, I've got to move that over. So it's going to be 58 point. I'm going to round to that value right there, and the 9 tells me to round that up to a 7. So it's going to be 58.7% of the total votes. So he just barely, our candidate just barely won the votes. Okay. 26, fill in the blank. Will is 30% taller than Wanda. So Will's height is what percent of Wanda's height? Well, so Will is Wanda's height plus another 30%. Well, Wanda's height is the 100%. So I just have to add those together. So Will is 130% of Wanda's height. 27. Make sure you practice this. We haven't done a lot of those in class. We didn't do a lot of the more than and converting it to of. So just make sure you try a couple of those. Maybe hit the similar question button a couple of times. 27, alcohol used by high school seniors in a certain state decreased from 49.9% to 36.5%. Describe this change as an absolute change in terms of percentage points and as a relative change. Okay, so I went from my original amount was 49.9. That was my old, right? My new amount is 36.5. So I'm going to do 36.5 minus my old amount, 49.9. So 36.5 minus 49.9. And that gives me negative 13.4. So that's the percentage points that I went down. But look at the way this is worded. The percentage of high school seniors decreased by, make sure you put 13.4 percentage points right there. Don't put negative, because this right here, it's the negative just tells us that it's decreasing. And they already said that it's decreasing. So we don't want to decrease by a negative, because that's actually increasing. Relative change, if we want to write this as relative change, remember, I have to take that same number, the 36.5, I'm going to minus the 49.9, but then I have to divide that by the 49.9. I have to divide that by the old. Remember that formula. So I'm going to do 36.5 minus 49.9, which hasn't changed. We just did that one. But now I have to divide that by 49.9. And it gives me this number right here, negative 0.26. Well, negative 0.26, what that means is 26%. It decreased, that's the negative part, by 26%. So I can write that. It wants us to round to the nearest tenth. So the 268, that 8's going to be my tenths, and that's going to round up to a 9. So that's going to round to 26.9. And again, it said decrease, so please don't put a negative in front of that. It's already saying that it decreased. Okay. 28, answer the question about the following quote. The unemployment rate has risen more than a percentage point to 8.6% in February from 6.7% last November. What is the relative change in unemployment rate expressed as a percentage? So here's where we need to be a little bit careful. So our new percentage point is 8.6. Our old is 6.7. And it wants this as a relative change. So I've got to divide that by 6.7. Okay. So when I do that, when I do 8.6 minus 6.7, be careful to hit enter, divide by 6.7. That gives me 0.28, which, remember, to make that a percentage, if you need to do it by timesing by 100, it tells me that the unemployment rate has risen 28.35% or 28.4%, because I'm rounding to the nearest tenth. So it has risen 28%. Okay, careful on those ones. 29, write each of the following numbers in scientific notation. So 59,000, I've got to move my decimal 1, 2, 3, 4. So that means 5.9 times 10 to the fourth power. Remember, this number needs to be between 0 and 10. We can't have a number bigger than 10. That's why we need it to be 5.9. This one here is going to end up 5.01. So to get there, I have to move 1, 2, 3, 4. But I'm moving it in the other direction. It's in the negative direction. I'm moving it to the right, so I'm going to put a negative 4 on that one. And then C, again, I'm going to write that as 4.0538 times 10. Well, I had to move it 1, 2, 3 places. So I'm going to put 10 to the third in order to get the correct number. All right. Okay, 30. Rewrite the following statement using a number in scientific notation. So 370 gigabytes. Recall that giga means billion. So what that means is 370 billion bytes. So I've got to put 0, 0, 0, 0, 0, 0. That's only 370 million, so I need 3 more. So to write this in scientific notation, it's going to be 3.7 times 10. Now to get to 3.7, I'm going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 places. I've got to move that 11 places to get it in the right place. All right. Okay, 31. Could an average person lift the weight of 100 dimes? A single dime weighs approximately 2.27 grams. Okay, so doing a little bit of math here, and then we'll worry about the conversion because, again, it doesn't give you that conversion, but we'll worry about that in a minute. A single dime, so 1 dime weighs 2.27 grams, and that's just 1 dime. Well, to get from 1 dime to $100 in dimes, to get to dollars, I'm going to have to multiply by 10, right? Or I guess I should put my dollars on top. So $1 on top, and my 10, that takes 10 dimes. So that gets rid of my dimes. Now to get from dollars, I want to get to $100, which means that I need that 100 on top, and I've got the 1 on the bottom. So what we're looking at here is I have in $100, each dollar has 10 dimes and there's $100. So I need to take that $100 and times it by each of those 100 has 10 dimes in it. Okay. So that's going to give me how many dimes? 1,000 dimes. That makes sense. There's 1,000 dimes in $100 because each dollar has 10 dimes. And that's probably easier than trying to deal with all of the canceling out when we're dealing with money that way. So if there's 1,000 dimes and each dime weighs 2.27 grams, I'm going to take 1,000 times 2.27. And that's going to give me what? 2,270, because that's just 1, 2, 3. Yeah. So 2,270 grams. Now, this question doesn't give us a conversion. It wants us to recognize how grams and pounds relate. And this might be a good one to memorize because I'm not sure if I'll be able to get the college to approve it being on your test. The way that we convert this, in 1 pound, there is about 450 grams. Okay, there's about 450 grams in 1 pound. So if I take this 2270 and I divide it by the 450, that gives me about 5 pounds. So basically I went 2270 grams and I'm timesing that by 1 pound over 450 grams to cancel out my grams. And I end up with about 5 pounds. So yes, you could pick that up because the weight of 1,000 dimes is only about 5 pounds. And look at that. It tells us right there, there's 1,000 dimes in $100. So we didn't even have to worry about converting it at all. We made it way harder than it needs to be. 32. Again, memorize this ratio. I'll work on it, but just make sure you've got that one down, okay? Find the scale ratio for the following map. 1 inch on the map represents 11 miles. So it wants to know how many inches does that represent in real life. So I need to take my 11 miles and I need to convert that into, let's start by converting it into feet. So I'm going to convert that because there's 5,280 feet in 1 mile. But then I want to get rid of, so that gets rid of my miles. But then I want to get rid of feet because I want to turn it into inches. Well, there's 12 inches in 1 foot. So I put the inches on top, so my feet cancel out. And then I just multiply. It looks like I'm going straight across, right? 11 times 5,280 times 12 is going to equal 696,960. So 696,000 960. So 696,960 would be my scale ratio. That's how many inches in real life are represented by that 1 inch on the map. All right, moving on. 33. I'm trying to balance this out for you guys. I know it's a long video. I'm trying to find you a good balance of enough detail to help you and not drag this out for a month. So state the number of significant digits and the implied precision. So looking at this number, there are 1, 2, 3, 4, 5, 6 significant digits. Okay. The implied precision is I look at the last place value right there. So these are tenths, these are hundredths, these are thousandths, these are 10,000ths. The last one is 100,000ths. So I'm looking for the nearest 100,000th of a mile. Okay, 34. Carry out the indicated operation and give your answer with the specified number of significant digits. So it tells us to do 49 times 32.3. I don't expect you to do that in your head, so go ahead and put it in the calculator. And I end up with 1582.7. But it only wants 3 significant digits. So there's going to be 1, there's going to be 2, which means I need to round to that tens place. So 1, 5. When I round, I look to the right. That 2 tells me to keep this in 8. So I'm going to get 1,580. And I'm not going to write 0.0 because I'm not that accurate. I'm only 3 significant digits with my accuracy, okay? Or with my precision, I guess. 35, for the pair of measurements, state which one is more accurate and which one is more precise. So your true height is 67.9 inches. A tape measure can read to the nearest 1/8 of an inch, gives your height as 67.38. A new laser device reads to the nearest 0.2 inches. Well, first of all, 1/8, if you don't have that memorized, 0.125. So this one measures to the nearest 0.2 inches. The tape measure measures to the nearest 0.125 inches. So the tape measure is more, well, I guess it's more precise. It gets us a better precise. It gets us a closer, a more precise measurement. But we've got to see how far away that is from our true height. So I'm really at 67.9. The tape measure says that I'm at 67 3/8. So I'm going to take 67.9 and I'm going to minus 67 3/8 is going to be what? 0.375. If you need to put that in your calculator, the 3/8, or you can write this as a mixed number. If you hit alpha y equals, you can actually use that option right there to write it as a mixed number. I'm not going to do that here. We know it's 0.375. So the tape measure was 0.525 off. The laser was at 69.4. So if I take 67.9 and I minus 69.4, I get 1.5. So the laser is less accurate and it's less precise. So the tape measure is both more accurate and more precise, which kind of surprises you, right? You would think that the laser might be more accurate. 36, use the appropriate rounding rules to do the following calculations. Express the result with correct precision or correct number of digits. So it wants me to divide 109 miles by 0.68 hours. So 109 divided by 0.68. And that gives me this great big number, 160.2941176. But it wants me to decide how I'm supposed to round this. Well, remember, we go with the number with the least significant digits, the least precise. So this 0.68, that's the least significant digits. So it's going to have me round this one to only 2 significant digits, which means I'm going to round, there's 1 significant, there's 2 significant. So I'm going to just round this to 160 miles per hour. I can't get more precise than that because I don't know if that's more, because I'm dividing the 109, I don't know if it's more accurate or more precise than 109. So we've got to go with that least number of significant digits there. All right, 37. State the number of significant digits and the implied precision. Well, we just did this, so we'll do this one quick. There's 1, 2, 3, 4, 5, 6 again. And we go tenths, hundredths, thousandths, 10,000ths, 100,000ths. So that's actually not just the same kind of question, but that's the exact same answer. Carry out the indicated operation. So here we go again. 41 times 32.5 gives me 1332.5, but it wants 3 significant digits. There's 1, there's 2, so I'm rounding to that digit right there. 1, 3. The 2 tells me not to round up. So 1330 is how I would round that one there. All right. For the pair of measurements, you know what? We just did that. That's exactly like, which one? We just did that problem. What number was it? You can go back and see number 35. Okay. So if you need to see another one of those, see number 35. I don't think we need to take the time to show 2 examples of the same problem. And same with 40. See number 36. If you're gonna round that one. Okay. 41. Find the monthly interest payment in the situation described below. Assume that the interest rate is 1/12 of the annual interest rate. Okay. So you maintain an average balance of $525 and it carries a 24% interest rate. So if I'm paying find the monthly interest payment. So all I'm looking for is the interest, which equals your principal times your rate times your time. So I'm looking for 24% is my annual. So I need to take that 0.24, but I need to divide that by 12 because I need my monthly amount. So 0.24 divided by 12, 0.24, divide that by 12, and you're going to get your 0.02. So my monthly interest is 0.02. It's just 2%. So if I take that 525 and our amount of time, this is just monthly, so it would just be 1. So we're not going to worry about time. Our balance times by our monthly interest, 0.02. So I'm going to times this by 525. And we're going to get $10.50. Okay. Prorate the following expenses and find the corresponding monthly expense. So land pays a semi-annual premium. So that's twice a year. So twice a year, he pays $650. So monthly, that means I've got to divide that by 6. A monthly premium of $135. So I'm going to add $135 because that's monthly. And an annual premium of $400. So I've got to take that yearly premium, the annual premium, and divide that by 12. And that'll give me, when I add all those together, it gives me my monthly amount. So I take the $650 and divide that by 6. And then I take the 135, which is itself. So let's take the 400, divide it by the 12. So $108.33 is my auto insurance a month. There is my health insurance each month. And then my life insurance is $33.33. So if I'm not going to round yet, I'm going to take this number and I'm going to add this number. And I'm also going to add my 135 to get my monthly amount. So that's $276. Now I'm going to round to 67 cents. Okay, wait till the very end to round your cents off. 43, prorate the following expenses. In filing his income tax, Paul reported annual contributions of $500 to a radio station. So monthly, that means 500 divided by 12, plus 195 to a TV station. So 195 divided by 12. 300 to a food bank. So 300 divided by 12. And 293 to other organizations. 293 divided by 12. Well, all of these are being divided by 12, so they have a common denominator. So I'm going to just add them all together first. Since they're all annual amounts, I'm going to add all of those together first. Then I'm going to divide by the 12 months in a year, and I get $107 and 33, let's see, 33 is going to round down to 33 cents. I got to remember to do that. In personal finance, we usually will always round money up to the next penny because that's how most businesses do it. But we'll just round following normal rules for this test. Okay. Number 44. The table shows the median annual earnings for women and men with various levels of education, assuming the difference in the table remains constant over 40 years. Approximately how much does a man with a bachelor's degree earn? How much more does a man with a bachelor's earn than a man with a high school? So what we're comparing is the bachelor's compared to the high school. Okay. So a man with a bachelor's makes $66,433 a month. So that means in a year, a month, makes that much per year, but we're finding over 40 years. So I'm going to times that amount by 40. So the bachelor's degree is going to make $2,657,320 in 40 years. Our high school guy is going to make about $40,000 a year. So we've got to take 40,367 times 40 years. So in 40 years, they're going to make $1,614,680. And it wants to know how much more our bachelor guy makes. So I just take my bachelor guy's amount and I subtract my high school guy's amount, and I end up with $1,042,640. And I'm not going to put the dollar sign because they already have the dollar sign there for me. Okay. 45, calculate the amount of money you'll have at the end of the indicated time period, assuming that you earn simple interest. Okay, so simple interest, it's on your formula sheet. It says that the amount that you have is equal to the principal amount, what you started with, multiplied by 1 plus your rate times your time. So in my calculator, I'm going to go ahead and do this math right here. So what I'm going to plug in is my principal amount is $3,800. And I'm going to do 1 plus my rate is 3.2. So I need to write that as 0.032. And I'm going to times that by 15. Okay, so 3800. I'm just plugging numbers in a formula. Parenthesis 1 plus 0.032 times the number of years, 15. And when I hit enter, my new amount after 15 years is $5,624. So after 15 years, that's a pretty good jump right there. I've gone up $1,800 just leaving my money sitting in a bank. Okay, 46, use the appropriate compound interest formula. Now that's not on your sheet yet. We are getting that added to the sheet that you're going to use on the test. But I guess the compound interest formula is, it's the continuous compounding, which isn't that on here? I think that's number 48. Okay, so we're just going to go ahead and use the one that you have on your formula sheet. So the principal amount, or I guess the amount that we have is going to be, the formula is principal times 1 plus the rate divided by the number of times it's compounded, raised to the number of times it's compounded a year times the number of years. So in this case, I plug in, here's my P, there's my principal amount. Here's my T, 5 years. Here's my rate, 4%. And when it says it's quarterly compounding, that means 4 times a year. So that's going to be my N is equal to 4. So when I plug all that in, A is going to equal 11,000, parenthesis 1 plus my rate, 0.04, over my number of times a year, 4 times a year, raised to the 4 times 5. So let's go ahead and plug that in. 11,000, parenthesis 1 plus 0.04 divided by 4, all raised to the 4 times 5. I'm going to go ahead and do that in my head. I can do that one. So after 5 years, I'm going to have $13,422, and it wants me to round to the nearest cent. So I'm going to round that to 9 cents, 0.09. Okay. And again, same idea. Use the appropriate compound interest formula. So we're going to use that same formula. But this time, our principal is 6,000. Our time is 14 years. Our rate is 2.66. And monthly compounding means every month. So that's going to happen 12 times a year. So I'm going to get 6,000, parenthesis 1 plus 0.0266. Ooh, careful writing that percentage. Divided by N, which is 12, multiplied or raised to the 12 times 14. So 6,000, parenthesis 1, nope, not 2, 1 plus 0.0266 divided by 12, all raised to the 12 times 14 power. So I'm going to hit enter, and that tells me that after 14 years, I'm going to have $8,703. And again, it wants me to round to the nearest cent, which is going to be 0.69 cents. Okay, that 2 is going to round away. So number 48. Now, this is the one I believe we don't have, there's not a formula on your paper yet. So continuous compounding interest. The formula that you need to use, the amount is going to equal, you take your principal and then you use the E, not just a random variable, but our mathematical E. It's right here with our LNs. You're going to take E and you're going to raise it to the rate times the time power. And then you're going to have to times that by 100. Okay. So when I plug this in, it wants to know the balance after 1 year, 5 year, 20 years, and then it also wants the APY, and I'll give you that formula in just a minute. But here's my principal amount. Here's my rate, and then my years are going to change as we go down here. Okay, so after 1 year, so I'm just going to fill this in, but with a 1. So it's going to be $400 times E to the rate, which is 0.027, times 1. So when I plug that in, I do 400, and then I do second E, 0.027, and it's just times 1. When I hit enter, it gives me my balance of 410.9, round to the nearest penny. So that 94 cents is going to actually round to 95 cents. And this one, it looks like it did our rounding that we needed it to do for us. So that's good. We'll leave it right like that. 5 years. So instead of a 5, I'm going to use the exact same formula, but up here, I'm going to put parenthesis point. Oh, is that? Yeah, 0.027 times 5. Close my parenthesis. Because this is after 5 years. My interest rate hasn't changed, but after 5 years, my balance is $457 and 81 cents. And then after 20 years, again, I'm going to use this same formula, but instead of a 5, I'm going to put a 20 right here. Now, if you're ever multiplying e raised to some power, make sure you put that in parentheses. Otherwise, it likes to do all kinds of funny multiplication for you. And that's going to give me $686.40 when I round to the nearest cent. Okay. Now it asks, what is the APY for the account? Now that formula, so APY, again, that is going to be on your test formula sheet. But so you have it for now, the APY is you actually take your E, the same E as before, but this time you raise it to the rate, and then you're going to minus 1, and watch what happens. So when I take my E, second E, and I raise that to my rate, which is 2.7, so I do 0.027. And then after I get that answer, I'm going to minus 1. And it gives me this is a rate. It gives me the rate. That's a percentage, 0.02736. If you want to see that come straight out as a percent, because this is asking for the percent, you can either move the decimal 2 places or you can times your formula by 100. Either way, it wants me to round to 2 decimals. So 2.7, and then this 6 right here is going to make that 3 round up to a 4. So it's saying that my interest rate that I'm actually getting because I'm compounding continuously isn't just 2.7%. I'm actually getting 2.74% by compounding that way.